Class, you made it through Easter vacation. I hope you had some awesome times and had a good Facebook Live sermon or two or three. I know I did and really enjoyed it. God bless you, and I hope you came closer to Christ through that time. Now we're back on our third week, starting on Tuesday, April the 14th of this home learning, and we're starting on our very last chapter. 12 is the last chapter we have. So, and every student that's ever gone through Trig has gone through SOHCAHTOA. So you see my letters there, SOH, the first three stand for sine is equal to the opposite over the hypotenuse, and SOH is there to help you to remember that. Then the second three are CAH, is cosine is adjacent over hypotenuse, and we'll help you to see that. And my favorite, TOA, is for tangent equals opposite over adjacent. Okay? Now, for us, when we look at these two triangles, triangle ABC is similar to triangle XCY. We're going to do the sine, which is the opposite to angle A. Opposite to angle A on the small one is 6, and the hypotenuse is 10, so 6 over 10. On the big triangle, opposite to angle X is 9 over the hypotenuse 15. So since they're similar, 6 over 10 equals 9 over 15, which both simplify to 3 over 5, which is equal to sine A and also sine X, since they're similar. Similar triangles have congruent corresponding angles. Now looking at the cosine, adjacent to angle A is the 8 between the A and the C, and the hypotenuse is still 10. On the bigger triangle, the cosine of X is 12 between the X and the Y, and the hypotenuse is still 15. Now both of these simplify to 4 over 5, which gives us cosine A equals to cosine X. And now tangent is the opposite to angle A, which is 6, over the adjacent to angle A, which is 8. And on the big triangle, the opposite to angle X is 9, the adjacent to angle X is 12, both of which simplify to 3/4 since they're similar, which is equal to tangent A and tangent X. Now for example 1, we're given a right triangle with the side of 5 and hypotenuse of 9. So we can say right off that sine of A is the side opposite A, or 5, over the hypotenuse 9, and for sines, we keep these out to 5 over 9 to 4 places rounded, so 0.5556. Now using the Pythagorean theorem to find AC, we can say that AC squared one of the legs plus 5 squared the other leg is equal to 9 squared, or AC squared plus 25 equals 81. Subtracting 25 from both sides, we have AC squared equals 56. And prime factoring 56, we see it's 2 times 28, and 28 is 2 times 14. So we can use 4 times 14 as the square root of 4 times the square root of 14 to give us AC is 2 square root of 14. Now when we do the sine and cosine, or the cosine and tangent, because we already did the sine, we have to deal with the square roots in AC. So cosine is the adjacent over hypotenuse, which we just found as 2 square root of 4 over 9, which comes out to 0.8315 on the calculator, 4 places rounded. And tangent A is opposite 5 over adjacent 2 square root of 14. And whenever I have a square root of 14 or any square root on the bottom, I multiply that top and bottom. So I end up with 5 square root of 14 over 2 times 14, or 28, which comes out to 0.6682. And now for example 2, we have a 3, and you might recognize 4, 5 right triangle, but if you don't, it's A squared plus 3 squared is 5 squared, A squared plus 9 equals 25. Subtract 9 from both sides, A squared is 16. A is the square root of 16, or 4. So sine A is opposite 4 over hypotenuse 5. Cosine A is adjacent 3 over hypotenuse 5. And tangent A is opposite 4 over adjacent 3. Now 45-45 right triangles is something that we've done a lot with in geometry, and we know that the sides are the same and that the hypotenuse is just square root of 2 times the sides. So when we do sine of 45, it's x over x squared root of 2. The x's cancel. We have to multiply square root of 2 over square root of 2, leaving us with square root of 2 over 2. Square root of 2 times square root of 2 is 2. Now cosine is the same as sine because the sides are the same, x and x, so it's square root of 2 over 2. And tangent of 45 is always opposite over adjacent. It's always x over x. Tangent of 45 is always 1. Now the other thing we did a lot with in geometry was the 30, 60, 90 triangle, which we always start by making an equilateral triangle. And here we're going to make the sides 2x, all the same all around. Now each angle would be equal also, and that would take the 180 for the big triangle divided by 3. So each angle in the equilateral triangle is 60 degrees with sides of 2x. And that's so I can conveniently cut the base into 2 equal pieces, x and x, and make 2 30, 60, 90 triangles because the top angle is 60 but bisected to 2 30s. So sine of 30, working on the left triangle, is opposite to the angle 30 is x over hypotenuse 2x is simply 1/2. Now cosine 30 is the altitude, x squared root of 3, and then a 30, 60, 90 right triangle, the long side is always square root of 3, the short side. So cosine is x squared root of 3 over 2x. The x's divide out, giving us square root of 3 over 2, which is cosine 30. Now tangent 30 is opposite over adjacent, so that's x over x squared root of 3. The x's cancel, and we have to multiply by square root of 3 over square root of 3, which gives us square root of 3 over 3. Now notice how the sine and cosine for 30 and 60 interchange. So the sine for 60 is the altitude, x squared root of 3 over 2x, which simplifies to square root of 3 over 2, which was cosine of 30. And cosine of 60 is adjacent x over 2x, or 1/2, which was sine of 30. Now tangent of 60 is opposite the altitude, x squared root of 3 over the side on the bottom, x, which is simplified to square root of 3. Now example 3, use your calculator to make sure you're in degree mode. Now find the second button on the top left corner. One button to the right is mode. Okay, so on the top row, second button in is mode. So once you punch mode, cursor down 3, and it'll show radians and degrees. So you make sure you cursor over to degrees if it's not there, and then to select degrees, make sure you hit enter so degrees is highlighted. That's how we have to set it for working in degrees. So now we can type sine of 30, and you'll find sine, cosine, and tangent all on one row in the fourth column, in the fourth row rather. So if you look from the top and go down 4 rows and 1 column left, you'll see sine and cosine and tangent buttons are all on the 4th row. So now you can type in sine 30, and that will mean sine 30 degrees. It'll come back as 0.5. Then you can do tangent 22.75, and it should come back as 0.4193 rounded to the 4 decimal places. Now here's something a little tricky, so I'm going to go over it once and then go over it at the end again. To do cosine 36 degrees, 40 minutes, 20 seconds, that's how that's read, we're going to go to the 3rd row, 2nd column is where we see math, and right over is apps. 1 over from math is apps. So to get degrees, after we type 36, we type second button apps 1, which selects degrees. To get minutes, we type second button apps button, and then 2, which selects minutes. Now this is a little different. To get seconds, we type alpha under the second button and then the normal plus key, and up should come a quote. It is actually a quote, but that's how we get our seconds. So to get cosine 36 degrees, 40 minutes, 20 seconds, which is 0.8021 rounded, we type cosine parentheses 36, second apse 1, 40, second apse 2, all on the same line, 20 alpha plus, close parentheses, and we should get 0.8021. Second, remember, is the top left corner usually green, alpha is right below it, or second is top left corner usually yellow, and alpha is right below it, usually green. So here we start our homework. Problem 2 is a nice 3, 4, 5 triangle, but we're asked about angle B, which is at the top. So sine B, remember, is opposite 4 over hypotenuse 5. Cosine B is adjacent 3 over hypotenuse 5. And tangent B is opposite 4 over adjacent 3. Now in 4, we have to deal with the square root of 61 being the hypotenuse, so we're going to have to clear out the bottoms with the square roots again. So sine E is opposite to E6 over square root of 61 times the square root of 61 over the square root of 61 is equal to 6 square roots of 61 over 61. And then cosine E is adjacent 5 over the square root of 61, and we do the same thing, coming up with 5 square root of 61 over 61. But tangent E is opposite 6 over adjacent 5, or just 6 over 5. Now for problem 6, we have sides of 4 and 6 and 2 square roots of 13. So sine X at the right is opposite 4 over hypotenuse 2 square roots of 13. So we have 2 over square root of 13 times the square root of 13 over square root of 13. Going through this again is 2 square roots of 13 over 13. Now cosine X is 6 over 2 square roots of 13, which is 3 over square roots of 13 times square root of 13 over square root of 13. Very similar to part A, is 3 square roots of 13 over 13. Now tangent X is opposite 4 over adjacent 6, which simplifies to 2/3. Now problem 8 is where we have to find the hypotenuse with sides of 16 and 30. So we need our calculator on all of this, but we really need it here. So c squared is equal to 16 squared plus 30 squared. Your calculator will tell you that 16 squared is 256 and 30 squared is 900. Adding those together, we get 1156, and the square root of 1156 is 34. So that's our hypotenuse. So now sine B, opposite to B, is 30 over hypotenuse 34 to 4 places is 0.8824. Cosine B is adjacent 16 over 34, 4 places, 0.4706. And tangent B is opposite 30 over adjacent 16 is 1.875. On problem 10, we have a nice 5, 12, 13 triangle, which means we don't have any square roots. So sine of H is to the far right bottom, opposite 5 over hypotenuse 13 to 4 places is 3846. Cosine H is adjacent 12 over 13 is 0.9231 to 4 places. And tangent H, opposite 5 over adjacent 12, is 0.4167. Now in 12, we do have to do square roots. So with the side 2 and a hypotenuse 4, we do 2 squared plus b squared equals 4 squared, or 4 plus b squared equals 16, and subtracting 4 from both sides, we have b squared is 12, which we're going to prime factor to 4 times 3 because 4 is a perfect square. So that when we get b, we have square root of 4 times square root of 3, which is 2 square roots of 3. So now sine n being the top point of the triangle, is opposite 2 over hypotenuse 4, or 0.5. Now cosine n is 2 square roots of 3, which we calculated, over 4, which simplifies to square root of 3 over 2, or 0.8660. And tangent n is opposite 2 over 2 square roots of 3. So that's 1 divided by the square root of 3 simplified, or 0.5774. Now straight on the calculator, we already have it set to degrees. Just type in cosine 40 and you should get 0.7660, and then type in sine 10.54 and you should get 8.1829. Now on 18, this was like the example we had, the longer one. So we want tangent of parentheses 7 degrees, which we do by 7 second apse 1, 18 minutes, which we do by 18 second apse 2, and 30 seconds, which we do by 30 alpha plus, and we should get 0.1283. See if you can do that. Now on 20, we have two sides, 4 and 7, and we have to find the hypotenuse. So c squared is 7 squared plus 4 squared, or 49 plus 16 equals 65. So c is the square root of 65. So we'll have to deal with that on sines and cosines again. So sine of q, the far right, is 4 opposite over square root of 65 times the square root of 65 over the square root of 65 comes out to 4 square roots of 65 over 65. Cosine of q is adjacent 7 over square root of 65, and it works the same way as a sine. So it comes out sine square root of 65 over 65. And then tangent q is opposite 4 over adjacent 7, 4 sevenths. Now 22, we have to find a side this time. So we have a side and a hypotenuse. So 5 squared plus b squared equals 11 squared. Or 25 plus b squared equals 121, and b squared equals 96. Now this is a little harder to prime factor to get the biggest perfect square. So the way I show you is the way to go. 96 is 2 times 48. 48 then being 3 times 16, because that gives us 16, the perfect square. And that we can use, b is equal to square root of 16 times the square root of 6, or 4 square roots of 6. Now then, sine k will be opposite k5 over hypotenuse 11. Cosine k will be what we just calculated, 4 square roots of 6 over 11. But tangent k will be 5 over 4 square roots of 6. And we'll have to multiply by square root of 6 over square root of 6, which will give us 5 square root of 6 over 4 times 6, or 24. Now 24 is a 45, 45, 90, so the two legs should be the same, and the hypotenuse should be the leg times the square root of 2, and indeed it is. And if you look here now, we'll see exactly the same as the one we did in the examples. Sine of v is 6 over 6 square roots of 2, which is 1 over square root of 2, times square root of 2 over 2, leaving square root of 2 over 2. Cosine v has exactly the same numbers, so it's also square root of 2 over 2. And tangent on a 45, 45, 90 is always 1, because the sides are the same, 6 over 6. Now, if you had any trouble doing the first one in the example and the one in the homework, cosine 36 degrees, 40 minutes, 20 seconds, let's do this step by step. So first, just do a regular cosine 36, which gives us 0.8090. Now let's do the same thing using the apse button. So now do cosine parentheses 36 second apse 1, which will give us degrees. We should get exactly the same answer, 0.8090. That shows you to make sure you can get the second apse 1 to work right. Then we'll add on the second apse 2. So we're going to do cosine 36 second apse 1, 40, second apse 2, and to make a difference between that and the last answer, we'll go out to 5 places, or 0.80212 you should be able to get. And now, finally, we're going to type cosine left parentheses 36 second apse 1, 40-second apps 20 alpha plus, remember alpha is right below second, and plus is down where you usually use plus, and it should come up as a quote. And to differentiate that in the last answer, we see 0.80206, or which is still rounded to 0.8021, but this is how it should look on your calculator, just like this. Cosine 36, the degree showing, 40, the single minute showing, and 20, the second showing when you type it in correctly before you hit enter. So see if you can master that, and we'll start on the next thing tomorrow. God bless you.